Hey, you absolute legends. My name is Don Cavanaugh, and this is talking about Chemical Equilibrium Lab, Part 1. This is our balanced chemical reaction that we are investigating with this two-part lab. We have iron interacting with a thiocyanate anion, producing a rusted red molecule that is iron thiocyanate. And just as a reminder, overall, we are trying to solve for the K value. So at the end of part 2, we will know all three of these molarities to plug in here and solve for K. But in part A, we have 3 tasks to complete our calibration curve. You're going to create 5 solutions and calculate the molarity of the iron thiocyanate of each of those 5 solutions. You're also going to use an instrument, a spectrophotometer, to measure the absorbance at 450 nanometers. And then finally that day, you're going to make an Excel plot with these numbers that you collect. Molarity will be on the x-axis, and absorbance will be on the y-axis. And it is expected that you make a scatter plot in Excel and find the y equals mx plus b, or the best fit line. The 5 solutions that you create for the Part A calibration plot or curve, I want you to understand that those solutions are designed to have a 100-fold excess of a reactant. We have 2 reactants present. And logically, if we have a huge excess of one of them, then we can bet that every single one of these will be produced into product. So for the examples, for your lab, do the labels, do the concentrations that are on the labels in your lab. But I'm using the ones that are on the table in the printout here. Our iron is what is going to be in excess. So this is our limiting reagent. This is what we're going to use here. In our first solution, we use 1 milliliter of this solution, and we want to calculate the final concentration, or the final molarity of our iron thiocyanate. The molarity of FeSCN is always going to be in moles per liters, because that is the definition of molarity, and we are going with the assumption that the moles of SCN equals the moles of FeSCN that will be produced, because we have a 100-fold excess of iron right here. So to calculate this right here, our moles of SCN, our molarity on that day This is the molarity that's written on the handout, but again, make sure you use the numbers from the bottle you use in lab that day. This is the molarity of the bottle, moles per liters. We used 1 milliliter of it. This will give us the moles of SCN, and because of this, we will immediately know the moles of iron. This is the moles of SCN we introduced, and every single one of these was produced into an FeSCN, and we immediately know the moles of FeSCN that were produced. And again, we're finding the molarity, so moles over liters. The total volume of solution that was made was 10 milliliters. So these, by definition, will be the molarity of the iron thiocyanate that was produced in solution 1. Using the numbers from the bottles you used on your lab day, you will calculate the molarity of all 5 of your solutions. Hint, they should be increasing as you go from solution 1 through 5 here, and these numbers will become the x-axis of the scatter plot that you're going to create on the end of day 1. I hope this helps. Thank you.